Okay, so this is lesson 9. I know that I wrote it in the agenda, but we will not be doing lesson 8 right now because that involved the graphing and stuff. So I'm not going to do that right now. But we're going to move on to the calculations of acceleration due to gravity. You already have learned an equation for acceleration. Okay, so we know that acceleration is v2 minus v1 over delta t. And it's the exact same thing. The only thing is whenever something is accelerating due to gravity, it's either you're tossing it upwards or you're dropping it. It's only under the influence of the gravity. So it's almost like the other term that we refer to it would be free falling. And when they have done that, it's like they've given you an extra value that if something is being drop or something is throwing outwards, what you know is that you actually have an extra value that is acceleration due to gravity is 9.8 meters per second. Okay, so if an object is dropped, the earth is falling towards the earth due to the force of gravity, and we say that it's accelerating downwards. The word we use is called free falling. And we assume that there's no air resistance. That's just an assumption to make the calculations easy. And we assume that the acceleration is always at the same rate. And the value that we use is 9.8 meters per second squared down. If you're afraid that you're not going to remember it, write it on your study notes, right? And the assumption is when it's near Earth's surface. Because if we're really far from the Earth's surface, the force of attraction would be a little bit less. And it's not going to it's not going to be the exact same value. So there is this assumption that it's very near the Earth's surface. Okay, we're going to talk about this thing called the terminal velocity. Okay, in real life though, there are going to be air resistance, and as the air resistance increase, eventually there's a speed that a certain object will reach, and then it's not accelerating anymore. So eventually the force of gravity acting down will equal to the force from the air resistance that's acting up. Okay, so what they're saying is that if I have an object, when it first starts falling, your force of gravity is really, really big acting on it, but at the same time it's going to have an upward force that we're going to call is an air resistance. As the speed increase, eventually your force of gravity won't change, but your force of air resistance is going to start to match up, that it will get to the point that the object will stop accelerating and it's going to start falling at a constant velocity. We call this the terminal velocity. So this is a definition application question. Okay, so definition of a terminal velocity is the maximum speed an object will reach when it's free falling. Some key terms you would need to know. Whenever they use the word drop, they're telling you that you have v1, which is the starting speed, is 0. And you also know when something is dropped, it's under the influence of accelerating due to gravity. I have 9.8. And another situation is if they tell you the object is at the maximum height. What they're implying is that as you throw something upwards, you know how it's going faster, and then eventually slow and slow and slow because it's actually going against the gravity. At maximum height, the object actually have a final velocity of 0. Acceleration is still 9.8. Okay? But when something is thrown down, you don't have a v1 equals to 0 anymore, but you still do have 9.8 equals to, a equals to 9.8 meters per second. Okay, so this is the first equation. I don't use the v and the f, so I'm just going to rewrite this. This is a equal v2 minus v1 over t. Okay, and if you're good in math, basically all these other equations is the same equation as this one, but they just rearrange the equation for the different values. So I'm going to show you how they got this, the second equation and so on and so forth, okay? But eventually we'll come back to this summary page. Okay, if I know A is V2 minus V1 over T. If the question wants to solve for V2, if this is what I'm trying to bring over, the first thing I would do is I would multiply this side. See how it used to be dividing t? To bring the t over to the other side, it becomes multiplying. So this now becomes A times T equals to V2 minus V1. And since I want the V2, that means I'm going to have to move this over to the other side. V2 minus V1, meaning it becomes a plus when I put it on the other side. And that's why they got that first equation. So this is equation number 1. The second equation that they got is V2 is going to equals to V1 adding AT. See, all I did is rearrange the equation. Okay, and then I'll go back to this. The next one they want to isolate is V1, equation 3. So I'm just going to call this equation 1, 2, 3, and 4. How did they get equation 3? From equation 2, if I would like V1 to be on its own, then I'm going to have to bring this guy all over because it used to be adding. It now becomes subtracting. So V1 is V2 minus a triangle T, or delta T. If I rewrite it a little bit better, I put my V1 on one side is V2 minus a delta T. Okay, the last one is, what if I'm solving for T? That's what the last equation, this equation number 4, do you see how I'm solving for T? Okay, solving for T, the easiest way to go is to go from this equation. Do you see T is at the bottom? We talked about this when we were doing the math lesson. When the unknown is at the bottom, the easiest thing you can do for yourself is almost do it like a cross multiplying and swap the place. So bring your T up and leave your A at the bottom. That's how you would rearrange the equation. So that's where the fourth equation comes about. All right, so let's just rewrite that. Okay, this is equation 1. They're all the same equation. They just rearrange it for you so that you can refer back to this. So my biggest suggestion for you is write this out on your study sheet, so that when you're doing a test or a quiz, you have it handy. If you're really good in math and you say, I don't need it, which is fine, you still need to memorize your first equation. Okay, like you always need to start off with one equation. Okay, so this is equation 1, 2, 3, 4, depending on what you need. So this is the one that I would definitely highlight, and I would definitely write it in your notes or something like that. Okay, first question. Now you gotta be careful. We talk about the special term. They give you extra stuff. A ball is dropped. We talk about that when they use the word drop. It means that they tell you that V1 is 0. Because when you're dropping something, you're not adding any force. You just let go. The initial or the starting speed is 0. And then it tells you it takes 3 seconds. It takes 3 seconds to reach the ground. What is this final speed? When it's 3 seconds, you write it in the proper variable. 3 seconds is time. So delta T is 3.0 seconds. You're going to be this careful writing out all your variables, right? Because I will look for them. They're asking you, what is your final speed? V2 is equals to what? That's my question mark. And we already just now said, when they say the word drop, which is also something you should be writing down. We go back to the page before. Something is dropped. I know V1 is 0. I also know A is 9.8. Okay. Now I'm going to figure out what equation to use. I'm looking for V2. So find the V2 equation that you would need. V2, so it will be equation number 2, right? V2 is V1 plus A delta T. Write out your equation. You get a mark for writing out your equation, or you would lose a mark if you don't, okay? So V2 is equals V1 plus A delta T. When the equation is properly arranged, now I just sub in what I know. V1 is 0, adding A, which is 9.8, and then multiply by T, which is 3. Punch it in the calculator, 0. You don't have to do anything about it. You can go 9.8 times 3. Punch it in the calculator. The answer is 29.4. And because I'm looking for speed, the unit is 29.4 meters per second. Not too bad? All right, try the next one. If you're brave enough, pause the video, read the question and write out the givens and see if you can solve for it without looking, and then check your answers back with me. That's a key thing with learning. When I'm going through an example, you try the question out yourself first, and then you test it. Give yourself time. If you just copy the notes and call it done, I don't know how much learning there are. But when you punch it in, it's like, I'm not seeing how I'm getting this answer. That's when you know, okay, I need to ask Ms. Chan the question. Does that make sense? Everything looks easy when I'm doing it because I've been doing it for 20 years, right? Okay, so this question, a rock is thrown straight up and reached the maximum height after 2.8 seconds. What is the initial speed? Okay, so I have maximum height. So go back to the note. When we say maximum height, we are given V2 is 0 and A is 9.8. Okay, so that means they gave us V2 is 0. I won't be able to tell you on the test. That means you need to either remember it or have it written out for you, right? A is 9.8. Like, I won't tell you that, I won't hint you. Remember what we said? I can't do that anymore, okay? And then the time is 2.8. Are you okay that 2.8 seconds means the time? Always look at the unit. That will tell you what the variable is. They would like you to find initial velocity. I don't know what I did there. Nice pen. All right, so V1 is what I'm trying to find. So now find the equation for V1. Go back to your equation, rearranging. I need the third equation because that is for V1. Did I tell you you should write these out on a piece of paper so you have it handy when you're doing the work? I think I said it 10 times. Now check your note. Do you have it written out, the 4 equation? If not, you pause the video and you write it out on this study notes. V1 is V2 minus A delta T. Right? Go back, just double checking. Yep. All right. So V2 is 0 minus A, which is 9.8 times T, which is 2.8. So, why negative? I got an answer of negative 27.44. What does a negative speed means? Okay, this is still in meters per second. What does that negative answer mean? What does this mean? Okay, it's actually the directions. Okay, like I'm tossing something upwards because if you remember, the acceleration of gravity is downwards. So this really means it's a negative down, but you're actually tossing it upward. I don't know if you recall from the earlier on lesson, when it's a vector, I just put a negative in front of it, means it's the opposite direction. So this really means 27.44 meters per second going upwards. If you just leave it as this, I would have marked it right already, okay? But if you write it like this, I'm like, okay, this person truly gets the vector and the negative value, what they mean. Okay, a ball is thrown straight up at 12.8 meters per second. How fast will it be going after 2 seconds? All right, so be careful. Let's deal with the vector sign. Okay, it's being thrown up at 12.8 meters per second. So this is V1 equals 12.8 meters per second. I'm going to write the direction down because you need it to match. They're asking you how fast will it be going. That's still a speed, but V2 is what they're looking for after 2 seconds. Okay, so the time is 2 seconds and is being thrown straight up, meaning V1 is not 0 anymore. But you always, this is the tricky part. I can see some of you forgetting this, but when something is being thrown upwards, we already mentioned in here, thrown up or down, you still have 9.8 because it's still free falling. Okay, I got an up and a down. We can't put it in the equation together with different direction. You're going to have to swap one of them. Do you want up or down? If you want to keep down, then what you do is you're going to have an So friendly reminder again, they have to be the same. The direction has to be the same. And to swap the direction, you just flip the direction. If it's up, you change it to down and you stick a negative in front of it. That's how we swap it. So I am going to decide to make it everybody down. Okay, so I'm going to change this to a down, but I can't just leave it. Something that is traveling upwards, it's the same thing as it's traveling negative downwards. Pick the equation. V2 is what I'm looking for. So V2 is V1 adding A delta T. You're welcome to use your equation sheet if you need, right? V1 is negative 12.8 adding 9.8 times T. Okay, punch it in your calculator. Negative 12.8 adding 9.8 times 2. The answer worked out to be 6.8 meters per second. Are we okay that is meters per second? Because it's speed. Speed is measured in meters, like how meters per second. And the direction that it's in, because we change